Okay, so now and we're going to do some very, very conceptual stuff here with chapter 11. First thing I want to do is ask you, what do you think a portfolio is? Yes.
It's a combination of
Yeah, and it's not just stocks. Could be bonds, could be real estate. So in other words, it's a collection of assets. It's a collection of assets. So far, all we've been talking about are the risk and return of individual assets. It turns out when you put stuff together in portfolios, the return of the portfolio actually behaves a little differently than you might expect based on the return of the individual items. Let's get some vocabulary out of the way here. The first thing we're going to talk about is expected return. Expected return is the return we expect on a stock over the next period. So it's a forecasted return. So is it known with certainty? No. In fact, it is a swag. You guys remember what a swag is? Ms. Wabi does. What is a swag?
a wild ass guess.
Yeah, it's a scientific wild ass guess, right? Okay, so that's what expected return is. It is our very best guess of what return is going to be in the future. Now, when we were in chapter 10 and we were finding the historical mean return for stocks, that was actually, we were calculating expected return, right? Or what's the best guess? What's our best guess on how much it's going to rain next year? Well, we take the last 10 years, add them together, divide by 10, and that's our best guess for next year. Does that make sense? Okay. Then we've got return variance and standard deviation. We've already talked about those, and we can do that not only for an individual stock, but you're going to see we can also do it for portfolios. And now we get into something that's important now that we're dealing with more than one asset, and that is covariance or correlation. Before I tell you what those things mean, let me explain to you through interpretive dance how portfolios, how it matters. So let's say we've got two stocks, and let's say those two stocks move together. Can you see that the risk of the portfolio would be identical to the risk of each stock, right? But, I gotta get back over here. What if they did this? When one is up, the other is down. And when I look at the return of that portfolio, instead of just following the path of one of the stocks, it looks more like, well, probably more like this, right? The highs are lower and the lows are higher. In other words, it smooths it out. It gets rid of some of that volatility. And so it matters how these stocks move with respect to each other. And so because you can't do interpretive dance on the exam, we have to come up with another way. And the other way, we have two things mathematically that measure how things move with respect to each other. We have covariance and correlation. Covariance and correlation. And I'm going to teach you how to calculate each of those things. Now, I'm going to tell you this. Correlation and covariance is only between two things. And so when we start looking at portfolios with three or more things in it, now we're having to look at covariances between these two, covariance between these two, covariance between these two. So now we've got three covariances that we have to worry about instead of one. But I'll give you some additional insight on that as we go. Questions? Okay, we're going to walk through these returns and then we'll call it good for the day. So we have two companies, SuperTech and Slowpoke. SuperTech, and by the way, they are in the same economy. How do I know? Because there are 4 states of the economy and they each have the same probability. So we're going to assume they're in the same economy. Now, states of the economy. Normal's kind of self-explanatory, normal time. What do we expect normal to be? Relatively low positive GDP growth. What is boom time? You know, things are growing faster than normal. Now, so far, we don't have any really hard and fast scientific definitions. We talk about recession. The definition, regardless of what Joe Biden's press secretary says, so I started studying this kind of stuff back in the 90s, and every time we would talk about recession, the answer was always 2 consecutive quarters of negative GDP growth. That was always the definition, until now, right? So let's stick with the old definition. 2 consecutive quarters of negative GDP growth. What does that mean? It means the economy shrinks 2 quarters in a row. By the way, quarter, how many months? 3. So we're talking about 6 months period of the economy shrinking is technically a recession. And then we have a depression. Is a depression worse than or better than a depression? Worse than. I mean, it's got the word depression in it, right? So how many depressions have we had in the last 100 years in this country? 1. How many recessions have we had? I've lost count, right? Since I was born, we had one 1981, we had one in the early 90s, we had the financial crisis one, we had the COVID one. We've had at least 4. I probably lost some. Oh, and there was one after September 11th. So probably I've lived through 5 recessions. I've lived through no depressions because I'm not that old. My point to you is recessions happen more frequently than depressions. We don't have a good scientific definition of depression, but I will tell you that it's just like the Supreme Court said about obscenity. Do you know what the Supreme Court said about obscenity? I recognize it when I see it, right? How do you recognize a depression? People are jumping out of buildings. 25% unemployment would be a good sign of a depression. Huge public works programs just to keep people basically employed and off the street. I mean, there are all sorts of things that point to it, but we don't have a good scientific definition of it. Now, let's look at the probability of each state of the economy. Depression, 10%. Recession, 20%. We know that recessions are more likely than depressions. That makes sense. Normal time, 50%. That makes sense too, right? And then boom time, 20%. Now, what happens if you add all of those together? What do you get? 1. You get 1 or 100%. And what does that mean? It means that we know every possible outcome. So what kind of statistics are we going to be using with these calculations? Population, right? Because we know everything. Any questions? Okay, next time we will start up here and we will continue on this slide. Remember, if you're coming to see your exam, bring your ID. So, last time we were talking about portfolios, and we were talking about how it matters how these things move with respect to each other. And so the first thing we're going to do is we're going to look at a very simple portfolio composed of 2 stocks, and only 2 stocks. And this is going to teach us a whole lot about the way portfolios work. And we went through last time the different stages of the economy. We said there was depression, recession, normal, and boom. By the way, is it always going to be those 4? No, sometimes they may only be 2 or 3 stages of the economy. But if you add the probabilities up for all of them, what do you think is always true? Yeah, it always adds up to 1.0 or 100%, so don't let that freak you out. In fact, you'll see after we get through calculating these, you would rather be working in a 2-state economy, right? Normal and boom or normal and recession, something like that, because it makes your work a lot easier. Okay, now let's talk about these 2 firms. We can see that for different states of the economy, the returns are different, and that makes all the sense in the world. The first one is Supertech. And in a depression, it loses 30%. Do you know that lose is a negative sign? Right? Lose is a negative sign. 30% is 0.30. In a depression, it loses 30% of its value. That makes a lot of sense, right? Because depression's a bad sort of time. Now, recession is going to lose 10% of its value. In normal times, the return is going to be positive 20, and in boom times, the return is going to be positive 50%. And so that's what we're seeing here. And in fact, what we would refer to this as is a normal or luxury goods company. I'm going to ask one of my economists. I'll start with Mr. Holman. What is a normal or luxury good?
Like the difference? Those are different things, obviously. But
Well, no. So I think economic definition, they use these interchangeably. Let's just cover up luxury. What's a normal good?
something that everyone need or will use on a normal basis.
Okay, now I'm going to try Miss Perry. Miss Perry.
Oh, I'm getting the same answer.
Oh my goodness. Okay, well let's go the other way. What's an inferior good?
Easy to substitute.
Okay. Okay, so obviously either I have totally forgotten all the economics I ever learned, or you guys didn't learn squat, so you need to get a refund on your tuition.
Isn't it inferior good as your income goes down, your demand for it goes up?
Whoa, she's on fire. Absolutely. I'm glad you came to class today. An inferior good is one that the demand for it goes up as times get worse and goes down as times get better. I'll give you an example. During the financial crisis, do you think people were buying luxury name brand stuff like Gucci and whatnot? No, everybody traded down. And so the people who were formerly shopping at Kohl's were now shopping at Target. We're talking about clothes. Shopping at Target, the people who used to shop at Target were shopping at Walmart. The people who used to shop at Walmart were going naked. And so if you look at the kind of clothes that they sold at Walmart, it's an inferior good. Not to say that it's of poor quality, but people just consume more of it when times are bad. Now let me give you another example of an inferior good. Cheap liquor. Cheap liquor. Why do you think people drink more during bad economic times?
Stress.
Stress. So they're trying to forget their troubles. I'm not recommending this path for you, but this is what people do. And so, but at the same time, do they have money to buy the good stuff? No. So there they are buying what's really nasty. Milwaukee's Beast, right? What's that?
Bush Light.
Aristocrat. I've never even heard of that.
Bush
Oh,
Light.
Aristocrat vodka. Yeah, okay. Totally misnamed, right? Because you think aristocrat sounds like a, okay. So now we understand what an inferior good is. If you had to guess, what is this other that we're talking about? Ms. Volkova, what do you think?
The normal or luxury is your demand for it goes up as your income goes up.
Yeah, your demand for it goes up as your income goes up. So, what kinds of things might we include here? How about golf clubs? Right? So, during bad economic times, do you think people are like, you know, I really need a new set of clubs? Yeah. What about luxury automobiles? Yeah, it's a normal or luxury good too. In fact, it's not just the person whose income gets hit that reduces the sales of these automobiles. It's also what happens to their neighbors. I'll give you an example. This was back during the financial crisis. My neighbor Larry and his wife were out walking a new puppy. And I said, oh, the puppy's so cute. What's the puppy's name? And his wife said the puppy's name is Audi, A-U-D-I. And I said, why is the puppy's name Audi? And she says, because it's the car we always wanted, but now we know we'll never be able to afford. I had been looking at an Audi A4 at that point. What do you think I bought? Nissan Altima. Now, I look back on that decision and with regret. But why did I not want to drive home in an Audi? It's like rubbing it in, right? You don't want to display wealth when other people are hurting. So, do you see how that it's not just Larry whose income was down because of the recession, it's his neighbors too. And so you'll see a lot of these that are really sensitive to the change in, say, GDP. Okay, so if we look at super tech, can you tell me whether it falls in this category or this category?
So luxury goods and other goods.
Yeah, it's more like this right here. It's more like that. And so it's a normal or luxury good. Now let's take a look at Slowpoke. In depression, 0% return. And you might say, well, zero kind of stinks. Well, compare it to what's going on at super tech. Oh yeah, hey, recently I would have loved to have 0% return on my investments. I'm down over 20%. right? That kind of stinks. I would love to have this 0% return at this point. In a recession, it returns 0.05. So it's actually got a positive return in recession. And then in normal times, we're up to 20%. But then what happens in boom times? It goes down. And so what kind of good would you say it is between these two? It's not perfect, but it looks more like this, right? And so maybe we're talking about inexpensive beer. Maybe we're talking about low-end golf clubs. Who knows? But it's obviously not one of these luxury goods. Now, why is that important? Because when the economy changes, it changes the returns of both of these firms and at the same time, right? And if they don't move perfectly together, these ups and downs kind of cancel each other out. And that's what we're going to see is the true magic of diversification, is to have things where these adverse motions kind of cancel each other out. Okay, now let's talk about how we're going to calculate variance and then standard deviation for each of these. So we're going to start out the same way. But the first thing, instead of figuring a historical average, what we're going to do is figure out something called the expected return. So remember, expected return is a swag. What does that swag stand for? Scientific wild-ass guess, right? But I'll tell you what makes it scientific. We have these probabilities and we have these returns given those outcomes. So that's what makes this scientific. So the expected return on the portfolio is equal to, what's that thing? It's a summation. If you're into the sorority fraternity thing, it's a sigma. It's a capital sigma. I is equal to 1 to n. We're going to have n things in this portfolio. Have I lost anybody so far? Okay, so then we're going to have the probability of state n. Oh, sorry, we've got n scenarios. So we've got n probabilities. So in this case, it would be 4. Right? We're not to the, actually, we're going to do this as a return for stock A. Sorry, I'm getting ahead of myself. Okay, the probability of the state of the economy n times the return of stock A in scenario n. Now don't let this freak you out. We're going to work through this so you can see exactly what this means. First of all, what is, we're working on super tech here, what is the probability of the first state of the economy, depression? Yeah, so we're looking at 0.10. You always want to use decimals when you're putting probabilities into an equation, or percentages of any kind. 0.10, and I'm going to multiply by the return, assuming that that state of the economy happens. If that state of the economy happens, super tech is down 30%. Does that make sense? Okay, can anyone guess what we're going to do next? What's the next number we're looking at here? Mr. Bowrichter.
Probability. Or wait.
Yeah?
Oh, the return.
No, you're, so probability return, what's the next thing we're going to do?
Oh, the number. No.
So, Mr. Bowrichter does not know. Mr. Taylor, what do you think we're going to do next?
I'm not sure either.
Okay. I'm going to give someone else a chance. So, someone besides Ms. Perry.
Recession.
Mr. Green.
Probability of recession.
Yeah, probability of recession, which we said is 20%. And now I'm going to give Mr. Bowrichter a chance to redeem himself.
Yes. Now it would be -10.
Yeah, very good. Okay, plus. Now, Mr. Taylor, what do you think we're going to do next?
I'm lost. I'm not gonna lie to you.
Okay. Let's see, Mr. Fogarty.
Not sure.
Oh my goodness, Ms. Wabi. Okay, so let's talk through this one more time. All we're doing is multiplying these two things together and then adding them all up. So far, we've had the probability of depression, the probability of recession. We've had the return for this stock given a depression. We've got the return for this stock given a recession. Ms. Wabi, did it occur to you then?
Yeah.
What's the next number I should be looking at here?
Wait, so which one are we doing? Super check or slow?
Super check!
Okay, wait. 0.20 times 0.5?
Okay, but you're doing it backwards.
Okay.
That's here. Yeah, so congratulations, that was a good shot. Okay, now, let's see. Mr. Taylor, are you with us now?
Yes, sir.
Oh, very good! What's the probability for this one?
Okay, so 0.20.
Very good. Times what?
Times 0.5.
Yeah, very good, thank you. Whew. See, this is why I learned your name, so I can put you on the spot. Mr. Osawabu, you're next. He says, not until you can pronounce my name correctly. Okay, back to the story. Now we can add these things up. And let's see here. What is 0.1 times negative 0.3? I think that's negative 0.03. Does that sound right? Yes. And this one is negative 0.02. Is that right? Okay, and then down here, 0.5 times 0.2, I think this is 0.10. And I think this is 0.10. Does that make sense? Now, if you're doing this on your calculator, which I firmly expect all of you except for Ms. Volkova to do because of how you grew up, right? What would you do? I would do this math, store 1. Do this math, store 2. Do this math, store 3. Do this math, store 4. And then add them all together to get the expected return. So I've got negative 0.03 plus negative 0.02. That gives me negative 0.05 plus 0.1 gives me 0.05 plus 0.10 gives me 0.15 or 15%. Now I want you to look above where it says Super Check, expected return equals. What does it say? 0.15. Now, did I have to give you that number at all? No. Will I give you that number on an exam? Undoubtedly not, right? No. Don't bet on it, right? Better to be prepared. Okay, so that's how we did that one. So now let's go back and we'll do the same thing only for slowpoke. So what am I going to do? I'm going to erase these numbers and I'm going to erase these returns, but I'm going to leave all the probabilities. Why can I leave all the probabilities? Because they're the same, right? Okay, so now the first one is 0.10. What's the return for slowpoke in depression? 0, right? What's the return in recession? 0.05, right? Okay, what is the return in normal times? 0.20. By the way, why do I put the 0 there? Because sometimes the decimal place gets lost in the fuzz, and that actually was a problem on one of those homework problems that you had for chapter 10, right? The decimal place on the, oh my goodness. And then over here, what's the return in boom? Yeah, negative 0.05. Now, I'm going to show you some mathematical trickery here to make your life easy. Are you ready? Nothing up my sleeve. Right. Okay, so tell me what you notice about these two things.
Same but negative.
Yeah, they're just same thing, opposite signs. So what can I do? They're gone, right? Because you're going to cancel each other out. Now, what do we know about this? Anything times 0 is 0, right? And so that's got to go too. So all we're really left with is 0.5 times 0.2, which is 0.10. And so that is our expected return for slowpoke. Now, can someone tell me what it says next to slowpoke expected return equal on the slide? 0.10. Once again, I didn't have to tell you that. You can calculate it for yourself. Questions? Okay, so that's always the first step in any of these things, is to figure out the expected return. Because what we're going to do next is, just like we did previously, we are going to figure out the deviation from the expected return for each of these situations. And so I'm going to start out with my negative 0.3, and then I'm going to subtract the expected return. What was the expected return for SuperTech? 0.15. So minus 3 minus 0.15 is minus 0.45. Is that what the slide says? I think we're there. Okay, and then I'm going to do that for each one of these. So minus 1 minus 0.15 is minus 0.25. 0.2 minus 0.15 is 0.05. And then down at the bottom we have 0.5 minus 0.15 is 0.35. Have I blown your mind yet? Now, so far everything's cool. Now, when we do variance, standard deviation type calculations, the next step is always to square the deviations, and that's what we do in the next column over. And by the way, what happens to that negative on the 0.45 when I square it?
Becomes positive.
Yeah, it becomes positive because a negative times a negative is a positive. So that gives us the 0.2025, and if I square negative 0.25, I get 0.0625. If I square 0.05, I get 0.0025, and if I square 0.35, I get 0.1225. Now, I'm going to share with you something that'll help you understand whether or not you got the whole number. If I square a 2 decimal point number, how many decimal points do I get? 4. If I square a 3 decimal place number, how many decimal places do I get? 6. If I square a 4 decimal place number, how many do I get? 8. Always going to be that way. And so if you're squaring a 4 decimal place number and your calculator says 0.27, something's wrong, right? You've got more numbers out there. Your calculator obviously has not been purified correctly. Okay, now, the very last step in this, and by the way, I'm going to work through all this on the calculator. The very last step in this is the part that trips students up the most. Because what we're used to is adding all together these squared values of the deviation and then dividing by n minus 1, which is what we did in chapter 10. But we're not working with a sample here, we're working with population. And so there is really only a 10% chance that the squared deviation is going to be 0.2025. There is a 20% chance that the squared deviation will be 0.0625. There is a 50% chance that it's going to be 0.0025. And there is a 20% chance that it's going to be 0.1225. So we can come up with an expected value for squared deviation, which, by the way, turns out to be variance. So that's what we're going to do. So what are we going to do? We're going to take the probability of each scenario, multiply it by the squared deviation. That's going to give us that final column over there. We're going to do that for all 4 of them, and then we're going to add all those together, and that's going to give us our variance. Now, if I want standard deviation and I've got my variance, what's the next step I need to take? Just take the square root of it, and now you've got your variance. Does that make sense? Okay, I'm going to walk through this on the calculator, and undoubtedly we'll have to do it more than once, but please pay attention. If you don't have your calculator out, this would be a really great time to get it out. Now, just like I told you last time, I don't want to work column by column. I want to work going straight across, because that way I only have to store 1 number per line. So I'm going to end up storing 4 numbers here. So here we go. I'm going to take 0.2 times, oh, no, sorry, I'm going to start at the very beginning. 0.3 negative minus the expected return of 0.15. That's where we get this negative 0.45. What's my next step? Square it. And so I'm going to hit this button right here. I'm getting the same number we got previously. And then the final number, what do we do?
Multiply the probability.
Yeah, multiply by the probability, multiply by 0.1 in this case, equals 0.02025. What do you think I'm going to do with this number? Store where? 1. Very good. Store 1. Okay. Now the next one is 0.1 minus 0.15 equals minus point. Oh crap. Where am I? Let me try this again. Minus, or 0.1. Oh, it's negative. That's why. Minus 0.15. Negative 0.25. What's my next step? Square it. And what's my next step after that? Yeah, multiply by the probability. 0.2 equal. So, what do I do now?
Store it.
Store where?
2.
2. Very good. Okay, Mr. Osawagwu, what do you think we're going to do next? Oh, no, we're not there yet. He's thinking ahead. Okay, I'll give you a hint. We're going to start with 0.2, and then we're going to subtract something. What are we going to subtract?
I wasn't playing that side.
Oh, Mr. Osawagwu, I appreciate you coming to my class. You're a good-looking man. But it really works better if you pay attention. Okay. Okay, so what we're going to do here is subtract the expected return. Can you tell me what the expected return is for this stock?
What would you have this dog?
Which one are we working on? The top one.
The top one. So it's 0.10.
The top one.
0.10.
The top one. It's SuperTech.
Yeah.
Yeah? What does it say SuperTech's expected return is?
0.10. 0.10. 0.
No! I'm going to circle it here with the... We all have those days, Mr. Osawagwu. This one's yours. Okay, there we go. That gives me 0.05. Now, I'm going to give you a chance to redeem yourself here. What do you think we do next? So I'm looking at this number right here. What am I going to do with that number next? To get this number right here.
So we square it.
Yeah, we're going to square it. Very good. Thank you. Okay. Now we've got that number. What's the next step? And I'm going to stop picking on Mr. Osawagwu here. Is it Ferguson?
Me?
No, we're...
Where?
Fitzgerald, sorry. He's another good Irish name. Yeah, we're going to multiply by the probability. I knew it was an Irish type name that started with F. So, what's the probability of this one?
0.5.
Yeah, 0.5. Now, what am I going to do? Store 3. Very good. Okay, now, finally, we've got... What am I going to type next? Ms. Wabi, what am I going to type next?
0.5.
0.5, very good. And what am I going to subtract?
0.15.
0.15, very good. She's on fire. We're going to keep going with her. What do we do next?
Square it.
Square it! And finally, for the quadrifecta here,
Multiply it by the probability.
very good. Thank you. Okay, now, what am I going to do with that number? Store it where?
4.
Very good. Store 4. Okay, now, as I mentioned earlier, the variance is just the expected value of that squared deviation. So that means all we've got to do is add these things up in order to get the variance. So let's see, Ms. Menace, how in the world are we going to get these numbers back and add them together?
You're gonna hit recall and then the number. that you're
Okay.
sorting on.
Recall 1
Plus recall 2.
plus, recall 2 plus, recall 3. She thinks it's so simple, she's not even going to go ahead and humor me by telling me the rest. Okay, so now we've got 0.0585. Is that the number we see on the slide? Yeah. Now, one more step. To get standard deviation, what do we need to do? Yeah, take the square root. So we're looking at roughly 24.19, and you can go ahead and write that number down if you like. In fact, let's see, I'm going to store that as 8. I don't think we're going to get to 8. Store it as 8. Okay. You'll see later that we're going to use that number again. Okay, now let's look at slowpoke. Now that we know how this sort of thing works, see if I can pick on someone else here. Mr. Corbin. Mr. Corbin, what am I going to do down here to figure out, what's my first step? The first number I'm going to type into the computer, or the calculator.
The 0.0.
Yeah, so it'd be 0 minus what?
Minus 0.15.
Ooh! Is that?
Oh, no, 0.1.
I was going to say, ask Mr. Osawoglu, he'll tell you it's 0.10, right? Okay. Now, so we've got negative 0.1 here. What do I do with that number? Mr. Corbin.
Is that when we multiply by the probability?
Oh, you're skipping
I
ahead.
know, I'm missing one step.
You're missing one step. I'll give you a hint. Do you see this right here?
Oh, take the square root.
Yeah. We're going to square it. We're going to square it. There you
That's what I
go.
meant to say.
Yeah.
Almost there, almost
It
there.
happens. Up is
And
down,
then we
left is
multiply
right.
it by the probability.
Very good. Thank you. He's eager to redeem himself. Can't say that to blame. There we go. 0.1. We got 0.001. What should I do with that? Store where? 1. Very good. Okay. That's so Ms. Ware, what should I put in next?
0.05
0.05, and what should I do?
minus 0.10
Minus 0.1 equals
square
square. Very good. And then?
multiplied by the probability.
And the probability is?
0.2.
0.2. And now, Ms. Ware, what should I do?
Store 2.
Very good. Store 2. Okay. I'm getting ready to pick on someone else. Who will my next victim be? Ms. Neuenschwander. I know you're probably 2 sheets to the wind by now, but...
You'll do, let's see, we just did 0.05.
Uh-huh.
So 0.20 times, or sorry, minus 0.10.
Uh-huh.
And then you square it.
Yeah. And then what do I do?
And then you're gonna multiply by probability, which is 0.5.
Very good. And then what will I do with that number?
You're gonna store it.
Store.
3.
Yep, store 3. Very good.
Now I have to go back and do it with my calculator.
Well, go ahead. You could play along at home while we're... Yeah. Okay. Mr. Fisher. Yeah. He's like, oh crap. There were 8 shots here and 29 students. I was thinking I'd get away with it. So what do you think we're going to do for that last one?
For that last one, we'll do negative 0.05
Very
minus
good.
0.1.
0.05 negative minus 0.1. Very good. You got the right number. What do we do next?
Square that.
Square it. And then what do we do?
Multiply it by 0.2.
Okay. Because that's the probability. And that gives us 0.0045. What do we do with that number? Store 4. Very good. Yeah, I thought you were going to fall down on that one, but I'm very impressed. Very impressed. Okay, Ms. Craybill, what are we going to do next?
Add, or I guess for call 1,
Uh-huh.
plus for call 2,
Uh-huh.
plus for call 3,
Uh-huh.
plus for call 4. Equals.
Very good. Now, I've got a variance of 0.011. Mr. Fogarty, if I want the standard deviation, what should I do?
Take the square root.
Very good. Take the square root. Mr. Fisher's thinking you got off easy. Okay, so we stored that other one in 8. I'm going to store this one in 9. Now, knowing what you know about standard deviation, which one of these stocks is riskier? Remember the standard deviation on the first one was 24.19%. This one's 10.49%. Which one of these stocks held by itself is riskier? Yeah, the first one has to be standard deviation higher. Remember we said standard deviation is our mathematical measure of risk. Do you guys remember that? Okay. Now, I also want you to look at the expected return. The expected return of the riskier one is higher. Does that make intuitive sense to you? Yeah. Okay, so far, nothing really shocking here. By the way, do you think you guys need to go back and practice this like 14 times? Well, maybe just 13. You need to practice it because even though right now you're sitting here thinking, oh, that looks right, it will escape from you. Okay. So now what we're really interested in is how these things move with respect to each other. Because remember I told you when you hold things in portfolios, it matters whether those things move together or whether they move in opposite directions. And so that's what we need to look at next. And we have two mathematical measures of how things move with respect to each other. The first is called covariance, which is very closely related to variance. I'll explain why here in a minute. And the other one is going to be called correlation. Correlation. Okay, now, how are we going to figure these things? Well, we're going to set up our same states of the economy. That one all makes sense. And then, instead of taking the deviation for one stock and squaring it, we're going to take the deviation of one stock and multiply it by the deviation of the other. And in fact, you can think of variance just being the covariance of a stock with itself. You can think of variance as just being the covariance of a stock with itself. Because if I were comparing SuperTech to SuperTech there, I would have negative 0.45 times negative 0.45, which is just negative 0.45 squared. And so if I do this covariance calculation using comparing a stock to itself, that gives me variance. So variance is just a very special case of covariance. Okay, let's see what else I can tell you. So now we're going to multiply those things together and get product of deviation. So instead of squaring, we're going to get the product of those deviations. And that's going to lead us to something new and interesting. And that is that we can have a negative in that column number 5. When we're squaring, was it possible to get a negative? No, because negative times a negative is always positive, positive times a positive is always positive. All those squared deviations are going to be positive, but when we start to look at these product of deviations, now it is entirely possible for these things to be negative. And it has a meaning to it. And the meaning is, if that particular scenario is negative product of deviations, it means these things are going in opposite directions. Either A is negative and B is positive, or A is positive and B is negative. Got to be that way. That tells you they're moving in opposite directions. Okay, so now we've got that product of deviations, and then just like we did for variance, we're going to take the probability of the state of the economy, we're going to multiply by that product of deviations, and that's going to give us column 6 out here, which is the product of the probability and this product of deviations. Now when I do that, I'm going to take column 6, which is the expected value of the product of deviations, and I'm going to add it all together. And when I add it all together, the number that pops out is not going to be variance, it's going to be covariance. It's not going to be variance, it's going to be covariance. And note, in this case, it's negative. It's negative. Could variance ever be negative? No, because you always got negative times negative or positive times positive. It's always going to be positive, but in this case, it's negative. Now, what does a negative covariance tell me? It tells me that these things have a tendency to be moving in opposite directions. They have a tendency to be moving in opposite directions. But I can't tell you anything really great about the magnitude because covariance has the same units as variance. Does anyone remember what the units of variance were? Something squared. What was it? It's percent squared, right? And so percent squared, we said, we don't know how to interpret that. So we don't know how to interpret this 0.001. And so after we get through calculating all this, I'll show you how to do that. And then I'm going to show you what we're going to have to do with that covariance number in order to be able to interpret it. So, does everyone have their calculators out and ready? Okay, get your calculator up. I'm going to hit clear. And in this case, what I'm going to start doing is just multiplying the deviations together to get this product of deviations, and then I'm going to multiply that product of deviations times the probability to get column 6. Okay, who have I not picked on? I know this is going to be confusing. Mr. Herberholt.
Which one?
I'm going to start with the vacationer. Ah, there you go. What do you think is the first number I should put in here?
001.
Oh, you're jumping way to the end. So what's the first step we're going to do here? I said we're going to take these things and come up with the product of deviations.
That's 0.45.
Very good. 0.45 times what?
0.10, negative 10.
Okay, so you got to be careful here. You gave me positive first, and I was willing to play along.
Oh, so I should have stayed positive.
You should either stay positive or
Yeah.
you should be, stay positive, man. Okay. So the trick is, first of all, I'm lazy. Secondly, I make mistakes. And so when I see a negative times a negative, I know it's going to be positive. Do I even type any of the negatives? No. And that was your first instinct, but then you strayed into the
Yeah.
bushes. Yeah. Okay. So now, what do other Mr. Herberholt? What do you think we should do next? Yeah, multiply by 0.1, and that gives us this last number. What should we do with that? Mr. Osawagwa, what do you think we're going to do with that number? Right here. What are we going to do with that number?
So we said the probability multiplied by the product of.
Okay, we already multiplied the product of deviations times the probability. That gives us this number right here. So we are at the end. What should we do?
Store.
Yeah, store where? Very good. Store 1. Clear. Mr. Bowrichter, what's next?
0.25 times 0.05.
And why could we leave the negatives off?
It's going to be positive.
It's going to be positive anyway. We get the same number. And then, I know there's someone I have not picked on yet. Ms. Bergner. Ms. Bergner, what should we do next?
And you multiply by the probability, so 0.2.
Yeah, very good. 0.0025. What should I do with this number, Ms. Bergner?
Store 2.
Very good. Okay, Mr. Green, what should we do next?
You're multiplying the 0.05 by 0.10.
Times 0.10 equal. What do we do next?
Multiply by the probability of the state of the county, 0.5.
Okay. And then what do we do? Store 3. Raise your hand if I haven't picked on you yet. Oh, very good. Let's see, now I can't remember where we were at. Which one did we just finish? The third one. Mr. Greeley, what should we do next? 0.35 times, oh, did you hear what he said? Times negative. Why do we have to go ahead and put the negative sign in, Mr. Greeley? Yeah, exactly. And so now I've got this minus 0.0525. Mr. Greeley, what do I do next?
And then you multiply it by 0.2.
Multiply by 0.2 equal, and I've got minus 0.0105. What do I do now? Store 4. Store 4. Okay, now let's see who else I haven't. And for some reason, your name escapes me. What's your last name?
Kilby.
Kilby. I should know that by now. I'm sorry. And I even have on my notes here that you have a beard. Yeah. If you ever shave.
I thought about shaving it.
Yeah,
because you said that last
it would
time.
just jack with me if you did. So of course that's probably what you'll do. Okay, so Mr. Kilby, now we have all these numbers. I hope we have all these numbers in our storage. What do we do?
We're gonna add them all up.
Yeah. So how are we going to do that? Tell me key by key.
Recall
1
plus
plus
recall 2
recall 2
plus
plus
recall 3
recall 3 plus.
recall 4.
I think we have a problem here. Did you see recall 2? recall 3. Okay, we don't have a problem, sorry. Recall 1 plus recall 2 plus recall 3 plus recall 4 equals minus 0.001. Is that what we're supposed to get? Yeah, that's the covariance of these things. They move in opposite directions, but once again, we don't know the extent of that. It's percent squared. We can't interpret it. So what we need to do is take it to a number that we can interpret. Now, when we were going to take variance to a number we could interpret, how do we go about that? We took the square root, right, to get it into standard deviation. What happens if we take the square root of minus 0.001?
Get an I.
You get an I. And what does I stand for?
Square root of -1.
Okay, so the square root of -1 is something called I. And it is known as an imaginary number.
My favorite imaginary number.
It's your favorite imaginary number. What other imaginary numbers do you know of?
I can't remember.
Exactly.
But
It's-
it's also because my high school teacher had like a song about swearing and stuff.
We won't ask you to sing that, right? I appreciate you bringing it up. Okay, so imaginary number. And so what we would get here is actually something called a complex number, which is, this is stuff they should have taught you in math. So a complex number has both a real portion and an imaginary portion. Now, when I was in the College of Engineering, we said the College of Engineering was very complex because we had both real disciplines, mechanical, chemical, civil, and imaginary disciplines, industrial engineering. Do you know what I spent most of my career doing? I was a mechanical engineer doing industrial engineering work. Okay, so there's your today's math lesson and your bad engineering humor. Okay, so what do we need to do then? We can't take the square root of this thing. We're going to have to find some other way. And so what we're going to do is calculate the correlation. So there's a nice formula there at the bottom. By the way, if there's a formula on the slides, what should you do with it? Yeah, put it on your note sheet, right? Okay, so correlation of stock A with stock B, in this case, Supertech with Slope Hope, is equal to the covariance of stock A with stock B divided by the product of the standard deviations of those two things. Now, here's something I want you to think about. I just told you that covariance has units of percent squared. What's the units for standard deviation? Oh. We said variance is in terms of percent squared. How do we get from variance to standard deviation? Square root. What's the square root of percent squared? Percent, right? So standard deviation is in terms of percent. So if I take percent squared, divide by percent times percent, what happens to the units?
They cancel.
They all cancel out. Correlation is unitless.
Wow.
Correlation is unitless. And you say, way to go, moron. You've taken us from something with units to something with absolutely no units whatsoever. How in the world does that help us out? I'll show you. But first we'll calculate the number, then I'll show you. Okay, so remember we have covariance. It should be still in our calculator. Oh, come on. There it is. And I saved those two standard deviations. Remember that? So I'm going to say divide by, open parentheses, recall 8 times recall 9, close parentheses, equals. So now I'm getting minus 0.039. Minus 0.039 still doesn't mean anything to you until we show you what correlation looks like. So covariance is not bound. It's not limited. So it could go all the way that way, it could go all the way this way. But it turns out the correlation is bounded on the upper bound by the number 1 and on the lower bound by -1. And here in the middle, it is 0. And if something has a correlation of 0, it means that the action of one of them has nothing to do with the action of the other. There's really there's no relationship between their movements. Okay, so where does my minus 0.04 basically fall on this scale?
To the left is 0.
Just to the left of 0. Right about here. Here is our minus 0.0394. So if I ask you this, is this thing closer to being perfectly negatively correlated or being uncorrelated? What's it closer to? Yeah, it's closer to being uncorrelated. This is why calculating the correlation helps us to understand the relationship. We can interpret it, whereas we could not interpret covariance. We could not interpret covariance, yes?
What is it, why are you doing to the power of 0.5 up there?
Oh! To the power of 0.5 is the same as the power of 1/2, which is precisely the same as square root. And so those numbers that you see there are variance, and we're taking the square root of the variance, gives us a standard deviation, but I had them stored in my calculator. Good question. That's why I stored them in my calculator, because I didn't want to muck with that.
Is there any reason to do it that way instead of just using the square root of the values from earlier?
No, perfectly fine to use the square root of the values from earlier. This is like the 14th time I've taught this, no, maybe 28th time I've taught this. And so that's why I knew to go ahead and store those numbers, because I knew where we were headed with it. So, by the way, when you guys calculate stuff like that, and you've got spare space in your storage, store 8, store 9, if you don't need it later, not a problem. If you do need it. What's better, storing stuff or writing it down? Storing stuff. Give me some reasons. Rounding error, number 2. Mistakes. And there are mistakes in 2 directions. There's the mistake of me writing it down, and then there's the mistake of me punching it back in. By the way, raise your hand if you're perfect, other than Miss Perry. Raise your hand. Nobody. Oh, you think you're perfect? No, he's messing with me. And by the way, he has a beard. Okay, so back to the story. I don't know why I can recognize you without writing beard on the sheet. I've really got a Kilby, right?
Yeah.
Very good. Okay.
I thought we on the test, I'm not.
Ooh, she just confessed her grade. Everyone cover your ears when people confess their grades. That's a violation of FERPA. Actually, it's only a violation if I tell them. You feel free to tell them, yeah. So I was teaching this China EMBA class, and I always, after exam 1, I would seat the lowest scoring people on the first row, the second scoring people on the third, and so, so they're all the way up. Everybody's looking at someone who did worse than they did, right? Since I'm not giving you a seated test, I can tell you my secret, right? And so these people, they figured it out. And they said, that's really an invasion of our privacy. And I'm like, what? And they said, you seat everybody where they're looking at someone who scored lower than them, so we know who scored worse. I said, how do you know? And she says, because we tell each other all our scores. I'm like, then how the hell is where I set you in any way, shape, or form a violation of your privacy? Okay, so in the whole scheme of things, this thing, we're looking at something that's really not all that correlated. And we just talked about all that. So now let's talk about some different correlation examples. And over here, we have what we call perfect positive correlation. And over here, we have perfect negative correlation. And here we have uncorrelated. Now, let's talk about what those things mean, because there's a simple case for both perfect positive and perfect negative that's really easy to catch. So here we go. Are you ready for more interpretive dance? If this one's up 1% and this one's up 1%, and this one's down 3% and this one's down 3%, and this one's up 1% and this one's up 1%, they are perfectly positively correlated. That's easy, easy, easy. But let me give you another example of perfect positive correlation. This one's up 1%, this one's up 3%. This one's down 1%, this one's down 3%. This one's up 2%, this one's up 6%. This one's down 3%, this one's down 9%. They're still perfectly positively correlated. And all I would have to do, well, we'll get to that in a minute. So here's the trick. How can I tell whether something's perfectly, positively correlated? If I take the deviation of one and divide by the deviation of the other and always get the same positive number, they are perfectly, positively correlated. If I take the deviation of one and divide by the deviation of the other, and for all cases, they always give me the same positive number, they are perfectly, positively correlated. Now let's talk about perfect negative correlation. The simple case, of course, down 1%, up 1%, up 2%, down 2%, down 3%, up 3%, right? Easy, easy, easy. But what about this? Down 1%, up 2%, up 2%, down, see, what did I say, 1 and 2? Yeah, down 4%. As long as I can divide one of the deviations by the other and always come up with the same negative number, then they are perfectly negatively correlated. If I can divide the deviation of A by the deviation of B and always come up with the same negative number, they are perfectly negatively correlated. And then we have the final thing, which is zero correlation. Zero correlation. That means that the movement of one has nothing to do with the movement of the other. The movement of one has nothing to do with the movement of the other. I will tell you, in this world, there are very few things that display a total zero correlation. And I was given this example one night in a night class, and I had two guys from Ghana there. I think they're called Ghanaians. But anyway, we were talking about correlations between different economies. And I mentioned that the United States and China, because of our economic relationship, we are positively correlated. If the United States is doing better, we buy more stuff from China. If the United States is doing worse, then we buy less stuff from China. So there's positive correlation there. Then we have Russia. And this was back before the fracking discovery. And in fact, I think we're back now pretty much in the same situation that we were before. And that is that high oil prices benefit Russian economy, but they hurt the U.S. economy. Does that make sense? Because they are a huge oil exporter. And so you would expect those two economies to be negatively correlated. And I made the statement that I don't think there are any economies that are uncorrelated. And the Ghanaians said, well, we are. And I said, why? And they said, well, we only have two real exports. We've got gold and chocolate. And we sell the gold to the Chinese and the Indians, and we sell the chocolate to the Europeans, so we don't have anything to do with you. I said, where do you think the Chinese get their money to buy the gold? Right? We're buying stuff from China, they're turning around. So my point to you is this. Finding zero correlations in the real world, very, very difficult. Questions? Okay. So now let's talk about how we're going to calculate the expected return for the portfolio. By the way, we said expected, anytime we hear the words expected return, we know it's a swag. So are we sure this is the correct number? No, it's our best guess. And what we're going to do here is we're going to find the expected return on the portfolio is equal to the probability of any of the scenarios multiplied by the return on the portfolio in that scenario. That's how we're going to find the expected return. But, sorry, I am getting ahead of myself here. I'm going to erase that. Forget that I said that. I will cut it out of the video. So let's talk about this. Expected return. We're not to the probability part. We've already done that. What we're going to do here is we're going to take the weights of the things in the portfolio. The weights of the things in the portfolio. And it turns out that we've got $60 worth of SuperTech and $40 worth of Slowpoke. And that's everything in our portfolio. Can anyone tell me the total value of the portfolio? Mr. Oomfleet, I don't think I picked on you today.
I don't think you have.
You didn't. Did you raise your hand when I asked if you'd been picked on?
You had already picked somebody.
Oh, so he was going.
You went too fast.
All right. Yeah. Okay. What's the value of the portfolio, the total portfolio?
$100.
100. Very good. And so now we're going to come up with what are called portfolio weights. And how are we going to come up with the portfolio weight? We're going to take the individual value of each thing in the portfolio and divide by the total portfolio value to come up with the weight for that thing. So, Mr. Umfleet, can you tell me what the weight on SuperTech should be?
On SuperTech, that would be 0.6.
0.6, and how did you get there?
60 divided by 100.
Very good. And the portfolio weight, good luck on your interview. The portfolio weight on Slowpoke, what should it be?
0.4.
0.4. And you came up with that as 40 divided by 100. Okay, now let's ask Mr. Taylor. If you add 0.6 and 0.4 together, what do you get? 1. It's always going to be the case. It's always going to be the case that when you add the portfolio weights together, you should get 1. If you don't, you've done something wrong. If you don't, you've done something wrong. Now, some students will take that piece of information and they'll say, aha! All I have to do is figure the weight on A, and then I just take 1 minus that to get the weight on B. You are missing a vital opportunity to check your work, right? Figure the weights independently, then add them all together to make sure that they work, and they add to 1, and if they do, you're good to go, and if they don't, you need to go back and look for your mistake.
That's much I can see you being cruel and adding a third stock in there, but only having us calculate the 2.
Ooh, very good. So more likely, I would tell you it's a $100 portfolio, you've got 30 of A, you've got 60 of B. What have I not told you? C. And how are you going to find C? You got to subtract, right? Oh yeah, she's absolutely right. I am cruel, 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 which means you need to practice, practice, practice. Okay, back to the story. Now we have the weights. In order to figure out the expected return on the portfolio, all it is the weighted average of the returns of the individual components. Now, we just figured the weights. All we got to do is take the weight on A times the expected return of A plus the weight on B times the expected return of B. Now, what if we had, as Ms. Perry says, what if we had 3 things? What would this formula look like? There would be one more term. What would it be? Plus X sub C times expected return on C. Does that make sense? Okay, but all we're doing here is a weighted average. All we're doing is a weighted average. So we're going to put all this stuff in here, 0.6 multiplied by that expected return on SuperTech, which we said was 15%, and then add the weight on Slowpoke times the expected return on Slowpoke, which was 10%. So for those of you who can't do the math really quick, I'm just going to tell you that's 9% plus 4% gives us 13%. Now it makes all the sense in the world that the return on the portfolio, the expected return, is going to come out somewhere between these two. Because after all, it is a weighted average. If I give you a 2 and a 4 and I ask you to come up with some sort of average between the two, it's always going to be somewhere between them, right? So that makes all the sense in the world. Okay. Now, where do we get expected return on A and B? Well, we calculated it if we had those probabilities and expected returns. In the real world, do you think we have those? No. We're going to use historical average as our expected return in the real world. And so when you see someone out in industry talking about the expected return on a portfolio, they're talking about historical returns. Now, what does every disclaimer for every investment company in the United States have to say? Past performance is no guarantee of future results, right? But it is our best guess. Does that make sense? Okay. Now we're going to look at the variance of a portfolio, and this is where it gets hairy. So what we just did was very simple. It's just a weighted average. Now we're going to look at the variance for this 2-asset portfolio, and it's going to go as follows. It is XA squared. What is XA? the weight on A, right? It's going to be the weight on A squared multiplied by, what is sigma squared sub A? Yeah, it's the variance of A, which is the standard deviation of A squared, same thing, plus xb squared, the weight on B squared, times the variance of B, plus 2 times xa, xb, covariance of A with B. That's what that sigma, if you see a sigma with just one letter after it, it's standard deviation. If you see a sigma with a something comma something, then it's a covariance. Don't let the sigma freak you out and think that this is a percent unit. It's not. It's just like variance. It's going to have percent squared units just like variance. Okay, now, so far this usually blows students' minds because it seems rather complex. But let's talk about what would happen if you had a 3-asset portfolio. So let's give that a shot. Are you ready? Xa squared times the variance of A squared plus xb squared times the variance of B, sorry, I don't mean variance squared, times the variance of B plus xc squared variance times variance of C plus 2xa xb covariance of A with B, 2xa xc covariance of A with C, and 2xb xc covariance of B with C. That's just with
It's like
3.
an alphabet.
Oh yeah! Oh, it gets worse, right? By the way, we can only have 26 pieces in our portfolio because we only have 26 letters. That is total bullshit. That is totally not true.
Start going AABB.
Oh yeah, she's going with the AABB, and I get
I always
that.
start using other languages.
Oh, very good.
Chinese
So-
characters.
So I have a new colleague, and so she was asking for my contact information because we were going to text about a dog sitter. And she hands her, she says, I start to tell her my info. She's like, oh, just type it in. She hands me her phone, and I'm like, is that Arabic? And she says, no, it's Farsi.
Oh.
And it turns out Farsi and Arabic are written in the same script, right? I said, do you really think that I'm going to be able to spell my name out with that? She's like, I'm sorry. Here you go. Okay.
Greek in mine.
What's that?
I have Greek in mine.
Yeah. The problem with Greek is when you start throwing in Greek letters, now what do people think we're talking about? They start thinking about covariance and variance and those sorts of things. Yeah.
I have it because of sorority and fraternities.
She's a sorority girl. Okay. Can you guess whether or not I was in a fraternity or sorority? Well, you could probably guess I wasn't in a sorority, right?
I mean, you could have been.
I was an engineering student. I didn't have time for that. I had to have my wife actually came to my room. That's how I met her, right? I wasn't out like looking because I didn't have time.
Many organizations are
What's
both
that?
sex. There are many organizations that have both sex on them.
Oh, okay. So in 1989, do you think that was true?
Yeah. Gamma Sigma Sigma.
Not at the University of Arkansas. Okay, back to the story. So, what do we do here? We're going to find this variance of the portfolio. We need to put the numbers in. The variance of A was 0.6, so we're going to square that. So let's get the calculators out and make this happen. And I'm going to break this down into three pieces. So we're going to say 0.6 squared times 0.0585 equals. What do you think I should do right now? Yeah, store 1. Clear. 0.4 squared times 0.011 equals. What should I do with that? Store 2. And then 2 times 0.6 times 0.4 times 0.001 negative equals. What should I do with that? Store 3. Then if I want to get the variance of the portfolio, what should I do? Recall 1 plus recall 2 plus recall 3 equals 0.02234. Now, someone asked earlier, what does 0.5 to the 0.5, is that you? Did I ask about okay, can you tell me what we should do next?
Square root.
Yeah, we're gonna hit the square root button. And that's gonna give us the standard deviation. So the standard deviation here is 14.95%. 14.95%. And if you think back, we had the standard deviation for Slowpoke was 10.49, and for SuperTech was like 24.19. Kind of makes sense that this is somewhere in the middle. Kind of makes sense, but we're gonna show you later that it doesn't necessarily have to be. So the question is this. Remember, we found the expected return being the weighted average of the the expected return on the portfolio was the weighted average of the expected returns on the individual pieces. Do you think that the standard deviation of the portfolio is merely the weighted average of the standard deviations of the components? Let's find out here. If we take 0.6 times the standard deviation of A plus 0.4 times the standard deviation of B, we get that one long number there, 0.187, which is 18.71%, which is actually more than our standard deviation that we calculated for the portfolio. And here's the reason why. If we do the weighted average of the standard deviations, it doesn't take into account how these things are moving with respect to each other. And so we're able to actually get rid of some of that risk by holding these things together in a portfolio because they don't move perfectly together. And we call that the magic of diversification. So here's the trick. If I have a portfolio and I can go out there and find any single stock that is not perfectly positively correlated with that portfolio, if I add that stock to my portfolio, I am going to get rid of some risk, but I am still going to get the weighted average expected return. And so it's like having your cake and eating it too. You're getting the return, which is the cake. Well, I guess they're both cake in this case. You're getting the return, but you're getting rid of some of the risk, which is also a good thing. Does that make sense? Okay. So I'm going to show you how this works. We're going to take this variance formula that we've been talking about, and we're going to rearrange it. Remember earlier I told you that covariance, or the correlation of A with B, was covariance of A with B divided by standard deviation of A times standard deviation of B. I didn't do it in Greek. That's the Greek right there. That Philadelphia Phillies thing is rho, right? Okay, so rho A comma B, that's correlation. Sigma A comma B is covariance. Sigma A is standard deviation. Sigma B is standard deviation. Okay, now I'm going to solve that thing for covariance of A with B, and it actually turns out to be correlation of A with B times standard deviation of A times standard deviation of B. And I'm just going to substitute that back in. And so now we get that formula on the bottom. And you see the only thing that's different is out there, instead of saying covariance of A with B, it says correlation of A with B times standard deviation of A times standard deviation of B. Only difference. By the way, should this be on your note sheet? Yeah, and you need to read carefully when you're doing these, because I could give you covariance or I could give you correlation, right? You need to read carefully. Ms. Wabi, I could see the stress headache building up there. Practice, practice, watch the video again. By the way, should you watch my videos late at night or when you've been drinking? No, especially
It could be a good drinking game.
I have actually had students tell me that. And when I told them that, they said, yeah, we watch your videos and we have a drinking game, but they never told me what the trigger was. Okay. Yeah, probably every time I say something stupid. Which might have been why the students didn't do so well in my class. Okay. So, now, if we put all these numbers back into the equation, and I'm not going to drag you through all these, but if I do all that out with a perfect positive correlation, it turns out that I get that weighted average standard deviation. In other words, the only way I don't get diversification benefit is if they are perfectly positively correlated. That's the only way I don't get diversification benefit. Students often think, well, they need to be negative correlated. No! Correlation to 0.99, I'm still getting some benefit. And so don't let that freak you out. And in fact, here's a great test question. You guys ready? What's the best correlation for diversification? And the answers are +1, 0, and -1. We know the +1's not the answer. What do you think's the most common answer? Should be -1, but the most common actual answer is actually 0. Why? No idea. I would rather have -1. If I could do this, and I'm going to prove this to you later, if I could do a perfect negative correlation, I could have the weighted average of the expected returns of the individual components and no risk. That would be sweet. By the way, spoiler alert, it never happens. Questions? Okay, I'll see you next time. Okay, so last time, here we were talking about the magic of diversification. Can anybody, in a nutshell, tell me what we mean by diversification, what the magic is, the diversification effect?
The more you diversify, the lower your risk is, it balances out your risk.
Okay.
High and low.
Yeah.
To be almost non-existent.
So what it really, so the scientific way I would say it is that the standard deviation of the returns on the portfolio are lower than the weighted average standard deviations of the individual parts. And that is the mathematical effect of the diversification effect, which is what she was talking about. Okay, now let's see if you were paying attention at all. When we calculated covariance correlation, did we work this way or this way? Yeah, across. And what do we do at the end of each one? Store 1, 2, 3, 4, right? Okay, so that last column, it's going to be a deviation times a deviation multiplied by what? Yeah, the probability of that economic state. What is the best correlation for diversification? -1. Very good. Now, does that mean, does it even have to be negative in order for it to, for you to get diversification? No. I saw Ms. Wabi shaking her head, yes. 0.99 will do it. Remember, anything less than 1. That's what we proved right here. If I throw a correlation of 1 into this formula, I get exactly the weighted average standard deviation of the individual components. But if that thing is any less than 1, then I get less than the weighted average of the standard deviation of the components. And so it doesn't have to be negative, and thank God it doesn't have to be negative, because most things in this world are positively correlated. There are a few that are negatively correlated. Most things are positive. But the cool thing is that as long as I have two things that are not correlated, as long as I keep adding stuff to my portfolio, I can continue to reduce that risk, which is a pretty cool thing. So let me give you a big portfolio example of that. You guys know what the S&P 500 is? So can anyone guess how many stocks are in the S&P 500? 500, very good. Okay, now S&P stands for Standard & Poor's. You don't need to know that. But what we can look at, we can look at the S&P 500, which by the way is a market value weighted index. Market value weighted index. Well, portfolio, when we're doing the expected return on the portfolio, we're doing market value weightings of those things in the portfolio. So if my stock is at 10% of the portfolio, it's going to be 0.10, the weight, right? So that's how we were figuring out the expected return on a portfolio. Okay, so we've got this, and it's a market value weighted index. And it's superior to the Dow Jones Industrial Average as a measure of the stock market for two reasons. Can anyone guess what they are? I'll give you a hint. How many stocks are in the Dow Jones? Ooh, try again.
41.
Try again.
Is it
30. Very good. 30. Okay, so we got 30 stocks versus 500. What do you think is a better measure? Do statisticians prefer a larger sample size or a smaller? Larger. Okay, so that's the first reason that it's superior. The second one is that the Dow Jones Industrial Average is price weighted, which means that a stock that has a high price pushes the Dow more than its market value would cause. And so those are the two reasons that I don't like the Dow Jones Industrial Average. And by the way, how come the Dow Jones stinks so bad? The originator of it was not a finance guy, not an economist. It was a newspaper guy. And what did the newspaper guy do? He chose 30 stocks that represented the U.S. economy, and he's added all the prices together. That's how we came up with the Dow Jones. And it drives me nuts. On TV, they're always like, well, the market was down today. And then they talk about the Dow Jones. I'm like, stop. Tell me about the S&P. Tell me the percentage the S&P was down. That's the information I need to know, not what some squirrely 30 stock portfolio has done. Okay, now, the next thing I want to point out to you is that the standard deviation on the S&P 500 index, which is this portfolio of 500 stocks, is 15.89%. 15.89%. Now, I want you to look at these stocks that are beneath there. It's kind of funny, you can tell this slide's old because some of these companies are dead. Ms. Avila, do you have a question?
No, so we're talking about the return on S&P 500 right now.
Okay, so let's address the dead elephant in the room. The stock market is taking a big dump, right? Now, and it's volatile. The standard deviation on returns is really high right now. Are any of you over the age of 30? You either are or you're
I
not.
turned 31 in November.
So you are over the age of 30.
I'm
Okay.
technically 30.
But you... You know, we could do this in probably an hour if it wasn't... Okay, back to the story. Should you care? No. I'm 15 years away from retirement. Do you think I'm losing any sleep over this? No. In fact, I'm looking at it the other way. I'm like, whew, glad prices are down. Now that however much a month that I put in there is getting me more shares, right? And it's so sad when people get freaked out because of the market being down. What do? They sell. And so, and when do they buy? When the stock's been going up for a while, they're like, oh yeah, I gotta get on this, right? And they jump in there and they buy. So they're buying high and selling low. How do you get rich on Wall Street? Buy low, sell high. They're totally missing the boat, right? So, stocks are up, great, I buy stock. Stocks are down, great, I buy stocks. Stocks are doing this, great, I buy stocks. Nuclear war, who's gonna care, right? By the way, we're closest to the nuclear war we've been since I was in high school. If you guys don't know about that, just do a little Googling. Back to the story. Yeah, there's your upbeat news for the day. Okay, now, check out the names of these companies beneath there. What do you think these companies have in common? I'll get you started. They're all part of the S&P 500. Now, take a look at the standard deviations of returns for all these firms. What do you notice about them?
Different.
They're different. He could be a detective. What else do we notice about them? Compare them. Yes.
They're all higher than the S&P.
Yeah, they're all higher than the S&P 500. Now, it doesn't have to be that way. In fact, there may be components of the S&P 500 that have a lower standard deviation than the S&P 500, but it isn't, this is a good thing to write down, it is entirely possible to have, it is entirely possible to have a portfolio standard deviation, a portfolio standard deviation that is lower than the lowest standard deviation of returns for a stock, for the lowest in the portfolio. And so it's possible to have a standard deviation of returns for the portfolio that's lower than the standard deviation of the lowest standard deviation stock. How is that possible? The miracle of diversification. It's possible because of the miracle of diversification. Questions? So let's talk about correlation and diversification. Knowing what you know about correlation. Think about two stocks of companies in the same industry. Do you think their correlation is positive or negative? Positive. They are hit by the same things in the industry, so all these outside forces are impacting them the same way. And so we could say that those correlations are probably pretty high, right? What about people who are in different industries? Disney, ExxonMobil. Do you think their correlations would be higher or lower than the two companies in the same industry?
Lower.
Yeah, they kind of got to be lower, right? Because the things that impact Disney, now of course oil price impacts both ExxonMobil and Disney, but Disney gets impacted by a whole lot of other things that ExxonMobil doesn't, and vice versa. And so the correlations on those are going to be lower. What's my point to you? If you invest all in the same industry, your portfolio is not as diversified as you might think. Okay, and I'll tell you a story about my dad, but we'll do that in the next set of slides. Any questions so far?